Okay, let's take a look at this Mod 5 Day 2 worksheet. If you numbered the pages in our packet in class, I think I called it page 9 of 10 this year. Okay, let's take a peek. Taking a look at the angle relationships, we're solving for x or y depending on the problem. This first one has x's. What is the relationship between these two different angles? Sometimes we have to do multiple steps to get there. So for example, this 3x minus 19 is on an exterior angle. And then here are two parallel lines. And then over here, it's not in the corresponding spot, meaning it's not in the same place here and here. So they're not equal. They're both exterior on the same side. Well, when one is small like this and one is large like this, those two angles are supplementary. So we're going to take the 3x minus 19 and the 9x minus 5, and we know that those two are going to add up to 180. So 3x and 9x is 12x, negative 19 and negative 5 is negative 24. Add 24 to both sides. And then 180 plus 24, I think that comes out to 204. And I'm dividing that by 12. You got it. X equals 17 degrees. So here it just wanted us to solve for x. So we got 17. Now, if you want to write a reason for this one, we could say 3x minus 19 and 9x minus 5 are same side exteriors, are supplementary. Just like we say same side interiors are supplementary, we could say that same side exteriors are supplementary. Okay, the next one, do you see how a number got cut off there? This is actually supposed to be a 1/3 x on this angle and then 118 on the other. So 1/3 x and 118, do you see that that forms a linear pair? So we're going to add those up and equal it to 180. 180 minus 118 is 62. And then how do I get rid of a 1/3? Yes, we multiply both sides by that denominator of 3. So 1x is equal to 62 times 3 is 186 degrees. So there's my answer with the degrees, and the reason was linear pair. Sorry that got cut off. It was a 1/3 x. All right, this next guy, we have to know that this little square means that inside there is a 90. Are you okay with that? Do you know that that symbol means 90? And then we are going to use the exterior angle theorem. Okay, exterior angle says that the exterior angle 10y plus 12 is equal to the sum of the remote interiors. So 90 plus 72 is 162 minus 12 from both sides. Gives us 150 divided by 10. And there we go. Did you get 15? By exterior angle theorem. All right, next one wants both an x and a y. Let's do the x's first so then we can solve backwards and then get y. So 2x plus 6 plus 3x minus 11. Do you see that those are same side interior angles or supplementary? So let's combine the x's and combine the constant. Do you see how I got that negative 5? 6 minus 11 gives me negative 5. And then 2x's plus 3x's is 5x's. So 185 divided by 5. Are you getting 37? And remember that degrees are your units. 37 degrees. Okay, and so the reason for that one is same side interior angles are supplementary. Okay, let's go do the next one. Now that I know that x is 37, I can say 3 times 37 minus 11. So 3 times 37 is 111 minus 11 is just going to be 100. So this whole angle right here is 100, and I'm trying to find the linear pair y. So I'm going to say 100 plus y is equal to 180. So y is equal to 80. Reason for that, linear pair. So there was 2 answers in part D, both X and Y. Okay, same thing for this next one coming up. There's going to be 2 answers. Let's do, okay, so if this is a 46 up here, then this is a 46 right here by alternate interior angles, right? So now that I see that that is 46, can't I do this entire thing right here? X plus 46 plus 70 has to equal 180 by adjacent angles on a straight angle. So that's 116 minusing 116 from both sides. I get 64 degrees for X. So now that I know this is 64 and I've got the 46 over here and I've got this Y. So let's put the 64 in here. This Y is equal to this Y because of vertical angles. So can't I just do triangle sum theorem? So here I go. Y plus 46 plus 64 has to equal 180 by triangle sum theorem. So y plus 46 plus 64 is 110. And I'm going to get y is equal to 70 degrees. All right, so I should have had 2 answers here, both x and y. Here's the y answer by triangle sum theorem. And here's the x answer by alternate interior angles are equal. And straight angle, I forgot to write that. Hang on. Adjacent angles that form a straight angle. Okay, so that's my other reason for this guy right here. Okay, moving down. Here comes reflect, rotate, and translate. Let's do the reflect and translate first and the rotate last as always. So A is 1, 6. So we go out 1, up 1, 2, 3, 4, 5, 6. B is 6, 6. And C is 4, 3. And then connect it. Here's A, here's B, and here's C. All right, so the first thing I'm going to do is reflect this across the x-axis. So the x-axis, remember, is this guy right here. So however far away, I'm going to go let's make this red. I'm going to go down 3, 1, 2, 3 to get to the axis. So I'm going to go 1, 2, 3 after the axis. There's my C prime. B is 1, 2, 3, 4, 5, 6. So I go 1, 2, 3, 4, 5, 6. There's my B prime. A is 1, 2, 3, 4, 5, 6. So I go 6 after. And there's my A prime. There's my reflection across the x-axis. Connect it. Okay, I'm going to highlight. There's my reflected triangle. All right, so that dot is now at 1, 2, 3, 4, 1, 2, 3. So 4, -3, 6, -6, 1, -6. Okay, reflected across that x-axis. Let's go down and do translate. Translate, so the coordinates of C are -5, 4. So -1, 2, 3, 4, 5, down 1, 2, 3, 4. Okay, so this is going, C is going back 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 1, 2, 3, 4, 5, 6, 7. So this is technically going back 9 and down 7. So taking A, back 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 7, 1, 2, 3, 4, 5, 6, 7. It technically goes off the graph by 1 line. There's my A triple prime. Here's my C triple prime. B, go back 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 7. There's my B triple prime, connect it. This purple is my translated. Let's go get those dots. A is at back 1, 2, 3, 4, 5, 6, 7, 8. So back 8 and down 1. B is at back 1, 2, 3, down 1. And C is at -5, 4 if we've done this correctly. -1, 2, 3, 4, 5, -1, 2, 3, 4. Good. Oh, I just wrote it on the wrong one. Let's write those all down here. Okay, now we're just left with the rotate. I'm going to make this last triangle blue. No, I already did blue, red. Let's do weird gold color. Okay, 90 degrees around the origin counterclockwise. So remember that a clock goes this way, so counterclockwise is going to go the opposite way. And we're rotating point A around the origin. So if this goes up 1, 2, 3, 4, 5, 6 over 1, A goes up 6 over 1. Sorry, I'm going to write this in black. It's not dark enough. Okay, so up 6 over 1 is going to become down 1 over 6, and it's got to land on the origin. So counting that backwards, here's my A double prime. So let me show you again how that counts. If this is up 6, right 1, this is down 1, right 6. I need to form that 90-degree angle. Okay, so here's my dot. All right, B, I go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So flipping that slope means I'm going to go down 6 and over 6. Here comes my B double prime. And last is C is up 3 over 1, 2, 3, 4. Flip to down 4, right 3. And there's my C double prime. Connect it. All right, so here we go. We're writing in those points. A, is it back 1, 2, 3, 4, 5, 6 up 1? B, is it back 6 up 6? And C, is it back 3 up 4? All right, there's your rotate, reflect, and translate. Last, we're doing a quick little triangle proof here. Prove each pair of triangles is congruent. Justify your answers by listing the corresponding congruent sides and angles. If the triangles are not congruent, say not congruent and explain why not. So notice here we have parallel lines. Parallel lines means we have alternate interior angles are equal. And we also have a reflexive side right here. And here's this right triangle, which means those are equal. So we can say that angle R is congruent to angle D because it was given in the image. We can say that AR is parallel to BD because it was given in the image. And because those are parallel, we can say that angle, how do I say that? RAB is congruent to angle DBA by alternate interior angles are equal. And last, we can say that AB is congruent to itself by the reflexive property. And so the triangle ABR is congruent to triangle BDA by angle side theorem. That's super squished in there. Hopefully you could figure that out. Okay, next one. Do you see how in this picture they told us that AN is congruent to GN from this marking right here? And they also told us that LN is congruent to EN. And so both of these were given. And then we can also state that these angles are congruent by vertical angle theorem. So angle ANL is congruent to angle GNE by vertical angle theorem. So then I can say the triangles are congruent. NLA is congruent to NEG by side angle side. So in both cases, the triangles were congruent. How'd you do?